Right now, as you're watching this video, you think you're made of solid matter. You think the chair you're sitting on, the phone in your hand, the walls around you, they're all real solid things. But what if I told you that's a complete illusion? What if everything you think is matter, your body, the earth, the stars, is actually just light that's been trapped, slowed down, and forced to follow specific rules? Not metaphorically, literally. In the next 3.5 hours, I'm going to prove to you that matter doesn't really exist the way you think it does. That what we call mass is actually just energy moving in circles. That you, right now, are made of the same stuff as the light coming from your screen, just arranged differently. And by the end of this video, you'll never look at reality the same way again? Here's the kicker. Physicists have known this for almost a century, but nobody talks about it this way because it sounds too crazy. But the math doesn't lie. Einstein literally proved that matter and energy are the same thing with E equals mc. But what does that actually mean? It means matter is frozen light. It means everything solid is actually just trapped energy vibrating in patterns. And before we dive in, if you're ready to have your mind completely reconstructed, hit that like button and subscribe, because this journey is going to get wild. Also, drop a comment below telling me what country you're watching from and what time it is where you are. Want to know where in the world people are having their reality shattered right now? Let's begin. So let's start with something simple. Light. You know what light is, right? It's that stuff that comes from the sun, from your screen, from light bulbs. Photons. Little packets of electromagnetic radiation traveling at the speed of light. No mass, no charge, just pure energy zipping through space at 299,792,458 meters per second. Now matter. That's different, right? Matter has mass. It has weight. You can touch it. It's made of atoms, protons, neutrons, electrons. Solid stuff, different from light in every way. Except it's not. In 1905, a 26-year-old patent clerk named Albert Einstein published a paper that would change everything. Special relativity. And buried in that paper was the most famous equation in history. E equals mc. Energy equals mass times the speed of light squared. Now, you've seen this equation a million times. It's on t-shirts. It's in every science class. But do you actually understand what it's telling you? It's not saying energy and mass are related. It's saying they're the same thing. Interchangeable. Mass is just a form of energy. Energy is just a form of mass. They're not two different things. They're two different states of the same thing. Think of it like ice and water. Different properties, different behaviors, but fundamentally the same substance in different forms. So if mass is just energy and light is pure energy, then matter is just organized light? Essentially, yes. But here's where it gets interesting. Light can't just become matter whenever it wants. There are rules. Specific, rigid rules that govern when and how energy can transform into mass. And those rules? They're what create the entire physical universe. Let me give you an analogy. Think of energy like money in a bank account. You can have it in different forms: cash, stocks, bonds, cryptocurrency. They're all wealth, just stored differently. E equals mc is like the exchange rate between these forms. And that c squared part, the speed of light squared, that's about 90 quadrillion. That means a tiny amount of mass converts to an enormous amount of energy. And vice versa. It takes an enormous amount of energy to create even a tiny bit of mass. This is why particle accelerators, like the Large Hadron Collider, have to be so massive and powerful. They're trying to convert energy back into matter. They slam particles together at nearly the speed of light, and in those collisions, the kinetic energy of motion gets converted into new particles. New matter. They're literally creating mass from pure energy, following the rules Einstein discovered. But here's what's truly bizarre. Those new particles they create, They only exist for fractions of a second before decaying back into energy. Matter is constantly flickering in and out of existence, transforming back and forth between mass and energy. The universe is like a cosmic dance where energy temporarily puts on a costume called matter, performs for a while, then transforms back into energy again. And this isn't just happening in particle accelerators. It's happening everywhere, all the time, including inside your body right now. But we're getting ahead of ourselves. First, we need to understand what light actually is, because if matter is just organized light, we need to know what we're working with. And light is way stranger than you think. For most of human history, people debated whether light was a particle or a wave. Isaac Newton thought it was particles, little bullets of light shooting through space. Christian Huygens thought it was waves, ripples in some invisible medium. They argued about this for centuries. Then, in the early 1800s, a guy named Thomas Young did an experiment that seemed to settle it once and for all. The double-slit experiment. He shone light through two narrow slits and watched the pattern it made on a screen behind him. If light were particles, you'd expect two bright lines, one behind each slit. But that's not what happened. Instead, he saw an interference pattern alternating bright and dark bands. This only makes sense if light is a wave. When waves pass through two slits, they spread out and overlap, creating regions where they reinforce each other, bright bands, and regions where they cancel each other out, dark bands. Think of it like ripples in a pond meeting and creating bigger waves or flat spots. The experiment proved light was a wave. Case closed, right? Not even close. Fast forward to 1905, Einstein's miracle year again. He's studying something called the photoelectric effect. When you shine light on certain metals, they emit electrons. But here's the weird part. The color of the light mattered, not the brightness. Bright red light couldn't knock electrons loose, but dim blue light could. If light were a wave, brightness should be what matters, more energy, more electrons ejected. But that's not what happened. Einstein realized light must come in discrete packets, little bundles of energy. The color of light determines how much energy each packet contains. Blue light packets have more energy than red light packets. It's not about how many packets you have, brightness. It's about how much energy each individual packet carries, color. He called these packets photons. Light was particles after all. So which is it, particles or waves? Here's the mind-blowing answer: both and neither. Light is something else entirely, something we don't have a good word for. They can behave like a particle in some situations and like a wave in others. This is called wave-particle duality, and it's not just light, it's everything. Electrons, protons, atoms, even you, everything in the universe has this dual nature. In fact, if you do the double-slit experiment with electrons instead of light, you get the same interference pattern. Electrons are matter, right? Particles with mass. But they create wave patterns. And if you try to measure which slit each electron goes through, if you try to catch them being particles, the interference pattern disappears, and you get two lines like you'd expect from particles. It's as if the electrons know they're being watched and change their behavior accordingly. The act of observation affects the outcome. This is quantum mechanics, and it's the foundation of everything we're about to discuss. Because if light behaves like matter and matter behaves like light, maybe they really are the same thing, just following different rules in different situations. Now, before we go deeper into the quantum realm, let me blow your mind with one more thing about light. You know how I said light travels at the speed of light? That sounds obvious, but think about what it means. From light's perspective, from a photon's point of view, time doesn't pass at all. Special relativity tells us that as you move faster, time slows down for you relative to someone standing still. This is called time dilation, and it's been proven experimentally countless times. Atomic clocks on fast-moving planes tick slower than identical clocks on the ground. GPS satellites have to account for this, or they give you wrong directions. But light is moving at the ultimate speed. Time doesn't just slow down for a photon, it stops completely. A photon emitted from a star 10 billion light years away experiences its entire journey, all 10 billion years from our perspective, as instant. From the photon's point of view, the moment it's created and the moment it's absorbed are the same moment. No time passes. It doesn't age. It doesn't decay. This means that from light's perspective, the entire universe is compressed to zero thickness in the direction it's traveling, and all events happen simultaneously. The Big Bang and the heat death of the universe are the same moment for a photon. It exists outside of time as we understand it. Now think about this. If matter is just light that's been slowed down and trapped in patterns, then matter is what happens when you take something that exists outside of time and force it to experience time. Matter is light that's been caught in space-time, and the rules that trap it, those are the fundamental forces of nature. But we're getting ahead of ourselves again. Before we can understand how light becomes matter, we need to understand what matter actually is at its deepest level. And that's where things get really weird. You think you know what an atom looks like. A nucleus in the center, protons and neutrons clustered together, with electrons orbiting around it like planets around a sun. You've seen the diagrams in every science textbook. That image is burned into your brain. That image is completely wrong. First of all, electrons don't orbit like planets. They exist in what are called orbital regions of probability, where they're likely to be found. But here's the kicker. Before you measure an electron's position, it doesn't have a definite position. It's not that we don't know where it is. It genuinely doesn't exist in a specific place. It exists in all allowed places simultaneously, in what's called a superposition. Only when you measure it does it collapse into a definite position. Before measurement, the electron is a cloud of probability, literally existing everywhere it's allowed to be at once. This isn't philosophy or interpretation. This is what the math of quantum mechanics tells us, and experiments confirm it over and over. But here's what really matters for our discussion. What is an electron? Not where is it, but what is it? Well, it's a fundamental particle, one of the basic building blocks of matter. It has mass, electric charge, and something called spin. But if you try to measure its size, you get zero. As far as we can tell, electrons are point particles with no physical extent. They're infinitely small. How can something with no size have mass? How can something occupy no space still exist? This is where the idea that matter is just trapped energy starts to make sense. An electron isn't a tiny ball of stuff. It's a quantum of energy that behaves as if it has mass because it's following certain rules, specifically conservation laws and quantum numbers that force it to interact with space-time in particular ways. Now let's look at the nucleus, protons and neutrons. These do have size. They're about a femtometer across, which is 1/4,000,000th of a meter. But here's the thing. Protons and neutrons aren't fundamental particles. They're made of smaller particles called quarks, held together by particles called gluons. A proton contains 3 quarks, 2 up quarks, and 1 down quark. But here's where it gets insane. If you add up the mass of those 3 quarks, you get about 9 MeV, mega electron volts, a unit of mass in particle physics. But the mass of a proton is 938 MeV. The quarks only account for about 1% of the proton's mass. Where's the other 99%? It's in the gluons and in the energy of the quarks moving around inside the proton. See, quarks are never alone. They're always bound together by the strong nuclear force mediated by gluons. And those gluons are constantly being created and destroyed, popping in and out of existence in the space between quarks. The quarks themselves are zipping around at significant fractions of the speed of light. All that motion, all that energy of confinement, all those virtual gluons flickering in and out, that's where the mass comes from. E equals mc, remember? The energy of the motion and the force fields gets converted into mass. A proton's mass is almost entirely just the energy of quarks and gluons trapped in a tiny volume, forced to follow the rules of the strong nuclear force. You are not made of matter. You're made of trapped energy. The vast majority of your mass, 99% of it, is the energy of quantum fields interacting in tightly confined spaces. You're not stuff. You're frozen motion. You're light moving in circles so tight and so fast that it appears solid. And this brings us to the central revelation of this entire video. What we call matter is just energy that's been caught in stable patterns by the fundamental forces. Light that's been slowed down, curled up, trapped in feedback loops where it can't escape. Matter is light in prison, and the bars of that prison are the rules of quantum field theory. But how does this happen? How does light become matter in the first place? To understand that, we need to talk about pair production, and this is where things get spectacular. Take a photon, a particle of light with enough energy, specifically more than 1.02 MeV. Bring it near an atomic nucleus, and watch what happens. The photon vanishes, and in its place appear two new particles, an electron and a positron. Matter has been created from pure light. Energy has transformed into mass right before your eyes. This process is called pair production, and it was first observed by physicist Carl Anderson in 1932. He was studying cosmic rays, high-energy particles from space, and saw tracks in a cloud chamber showing particles appearing from seemingly nowhere. A photon had converted into an electron and its antimatter twin, a positron. But notice the rules here. The photon couldn't just become any particles. It became an electron-positron pair. Why? Because of conservation laws. Electric charge must be conserved. The photon had zero charge, so the total charge of the created particles must also be zero. An electron has negative charge. A positron has positive charge. They cancel out. 0 equals 0. Rule followed. Energy must be conserved. The photon's energy must equal the mass energy of the electron and positron plus their kinetic energy. An electron has a rest mass of 0.511 MeV. So does a positron. Together, that's 1.022 MeV. The photon needs at least that much energy to create them, plus whatever kinetic energy they'll have when they appear. Rule followed. Other quantum numbers must be conserved: 2 lepton number, momentum, angular momentum. Every conservation law must be satisfied for pair production to occur. Light doesn't just randomly become matter. It transforms into matter in very specific ways that preserve every conserved quantity in the universe. And here's the beautiful symmetry. The process works in reverse. Bring an electron and a positron together, and they annihilate. They vanish in a flash of light, converting back into photons. Matter becomes energy again. The circle completes. This happens constantly in the universe. Near black holes, where gravity is so intense that space-time itself warps dramatically, virtual particle pairs pop into existence from the vacuum. One falls into the black hole, the other escapes as radiation. This is Hawking radiation, predicted by Stephen Hawking in 1974. Black holes slowly evaporate by converting their mass into light. In the early universe, when temperatures were trillions of degrees and the average photon had enormous energy, pair production happened constantly. Particles and antiparticles were created from light, met, annihilated back into light, over and over. Matter and energy were in equilibrium, constantly transforming into each other. As the universe expanded and cooled, something broke that symmetry. There was slightly more matter than antimatter, about 1 extra matter particle for every billion matter-antimatter pairs. Nobody knows why. This is one of the great unsolved mysteries in physics. But because of that tiny imbalance, when the universe cooled enough that pair production stopped, there was a little bit of matter left over after all the antimatter had found matter to annihilate with. That leftover matter That residue is everything. Every galaxy, every star, every planet, every atom in your body. You exist because of a 1 in a billion asymmetry in the early universe. You're the remainder when nearly infinite matter and antimatter canceled each other out. You're what's left when light transformed into matter, and almost, but not quite all, transformed back. So matter's light plus rules, plus a cosmic accident. But we still haven't answered the deeper question. What are those rules? What actually determines how energy can organize itself into matter? Why can a photon become an electron, but not a quark? Why do particles have the masses they have? Why do the forces work the way they do? To answer that, we need to talk about fields. And this is where reality gets truly strange. You don't think in terms of fields. You think in terms of particles. An electron here, a photon there. Discrete objects moving through empty space. But that's not how modern physics views reality. At the deepest level, there are no particles. There are only fields. A field is something that has a value at every point in space. Think of a temperature map showing the temperature at every location in a room. That's a field number, temperature, assigned to each point in space. Or think of the surface of the ocean at each point. The water has a height. The height field describes the entire ocean's surface. Now, quantum field theory says that every type of particle is actually a ripple and excitation in an underlying field that fills all of space. There's an electron field pervading the entire universe. When that field gets excited in a particular way, we observe what we call an electron a particle. But it's not really a particle. It's a wave in the electron field, a localized disturbance that propagates through space. Same with photons. There's an electromagnetic field everywhere. Ripples in that field are what we call light. Protons and neutrons are excitations in the quark and gluon fields. Everything you think of as a particle is actually a wave in a quantum field. This resolves the wave-particle duality weirdness. Things behave like waves because they are waves, and fields. But these fields are quantized, meaning the energy they carry comes in discrete packets. When you measure a particle, you're detecting a quantum of energy in a field. That quantum behaves like a localized object, a particle, but its underlying nature is a wave. And here's where it connects to our central idea. If everything is fields, and matter is just excitations in these fields, then light and matter are fundamentally the same kind of thing. Photons are ripples in the electromagnetic field. Electrons are ripples in the electron field. But these fields all exist in the same space. They all interact according to the same quantum mechanical rules. And under the right conditions, excitations in one field can transform into excitations in another. Light becomes matter when energy from the electromagnetic field gets transferred to the electron field and positron field in a way that satisfies all the conservation laws. Matter becomes light when excitations in matter fields release their energy back into the electromagnetic field. It's all just energy moving between different quantum fields following precise mathematical rules. But why these fields? Why an electron field and not a unicorn field? This is where we get to the standard model of particle physics. And the answer is both beautiful and deeply strange. The standard model says there are a few dozen fundamental fields in the universe. 6 quark fields, 6 lepton fields, including the electron, 4 force-carrying fields, photon, gluons, W and Z bosons, and the Higgs field. That's it. Everything in the universe, everything you see, touch, experience, is made from excitations in these fields. And the reason these specific fields exist, with these specific properties, comes down to symmetry. Not the everyday meaning of symmetry like a butterfly's wings matching, but mathematical symmetry invariance under transformations. The laws of physics look the same if you rotate your experiment, or shift it in space, or run it at a different time. Those symmetries aren't just coincidences, they're fundamental, and they dictate what fields can exist and how they must interact. There's a deep principle in physics discovered by Emmy Noether in 1915. Every symmetry corresponds to a conservation law. The fact that physics is the same everywhere in space means momentum is conserved. The fact that physics is the same at all times means energy is conserved. The fact that physics is the same regardless of your orientation means angular momentum is conserved. But there are more subtle symmetries, two-gauge symmetries, and these determine the fundamental forces. The symmetry of the electromagnetic field mathematically described by the group U(1) requires the existence of the photon and determines how it interacts with charged particles. The symmetries of the strong nuclear force, described by SU(3), require gluons and determine how they bind quarks. The fields exist and have the properties they do because of underlying mathematical symmetries in spacetime. Matter is light following rules, and those rules are written in the language of symmetry groups and conservation laws. The universe is a mathematical pattern, and matter is what that pattern looks like when energy organizes itself according to the equations. Now, I know that's getting abstract, so let me bring it back to something tangible. You, your body. What are you actually made of? You're about 65% water. Water is He(O)2 hydrogen atoms and one oxygen atom. Each hydrogen atom has one proton and one electron. Each oxygen atom has 8 protons, 8 neutrons, and 8 electrons. So you're mostly protons, neutrons, and electrons arranged into atoms and molecules. But we've already established that protons and neutrons are 99% just energy quarks and gluons moving around at high speed, confined by the strong force. And electrons are point particles, excitations in the electron field. So you're made of 1% quark matter, 99% binding energy forming protons and neutrons, arranged into atoms held together by electromagnetic forces between electrons and protons, organized into molecules held together by shared electrons, structured into cells maintained by chemical reactions, which are just electrons rearranging between atoms, assembled into tissues and organs, and ultimately a living system that can think and experience. At every level, it's energy organized by rules. You're not made of stuff, you're made of relationships. The relationship between quarks via gluons. The relationship between electrons and protons via photons. The relationship between atoms via shared electron clouds. You're a pattern of energy held together by forces. A stable configuration that persists because it follows all the conservation laws. And here's what really bends your mind. Most of you is empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be tiny grains of sand in the stands. Everything in between? Nothing. Vacuum. Empty space. Except it's not empty. It's full of fields. The electromagnetic field that holds your atoms together fills all that space. Virtual particles, photons, electron-positron pairs, even heavier particles are constantly popping in and out of existence in that empty space, lasting for impossibly brief moments before annihilating. These quantum fluctuations are real. They produce measurable effects like the Casimir force and the Lamb shift. So even the emptiness inside you is seething with activity. The vacuum is alive with fields fluctuating, virtual particles briefly materializing then vanishing, energy borrowed from uncertainty and paid back. You're not mostly empty space, you're mostly quantum fields in their ground state, with a few localized excitations we call particles scattered throughout. You are, quite literally, light and force fields arranged in a stable pattern complex enough to be conscious. You're the universe experiencing itself. And that leads us to the question we've been building toward. If matter is just organized energy following rules, who wrote the rules? Why these symmetries? Why these forces? Why is the universe mathematical at all? Before we dive into that profound question, this is a good moment to pause and process what we've covered. We're about 90 minutes into this journey, and if your brain feels like it's been rewired, that's normal. We've gone from thinking matter as solid stuff to understanding its ripples in quantum fields. From thinking light and matter are different to realizing they're two forms of the same thing. If this is blowing your mind, hit that like button to let me know. And if you've stuck with me this far, you're clearly someone who doesn't settle for surface-level explanations. Subscribe so you don't miss future deep dives like this. Drop a comment telling me, what's the most mind-bending thing you've learned so far? I read every comment. All right, let's tackle the big question. Why these rules? One answer, popular in some physics circles, is the anthropic principle. The rules are what they are, because if they were different, we wouldn't be here to ask the question. It's a selection effect. We necessarily observe a universe capable of producing observers. In a universe where the strong force was slightly weaker, atomic nuclei couldn't form. Slightly stronger, hydrogen would all fuse into heavier elements immediately. Either way, no stars, no chemistry, no life. So of course, we find ourselves in a universe fine-tuned for existence. We couldn't exist in any other kind. But that feels like a non-answer to many physicists. It doesn't explain why the universe is mathematical, or why these specific symmetries, or why quantum mechanics works the way it does. It just says if it were different, we wouldn't be here. True, but unsatisfying. Another approach is the multiverse hypothesis. Maybe there are infinite universes, each with different laws of physics, different fundamental constants, different rules. We happen to be in one where the rules allow complex structures like matter and life. It's the anthropic principle taken to the extreme. Of course, our universe seems special because we're sampling from the tiny subset of universes capable of producing beings to observe them. This is unprovable and maybe unprovable, which makes many physicists uncomfortable. But it's worth noting that several theoretical frameworks, eternal inflation, string theory, quantum mechanics under many worlds, interpretation naturally produce something like a multiverse as a consequence of their mathematics. A third perspective, and one I find fascinating, is that the universe is fundamentally mathematical. Not that it's described by mathematics, that it is mathematics. The physicist Max Tegmark has championed this view. In this framework, every logically consistent mathematical structure exists as a universe. Physical existence isn't something separate from mathematical existence. It's the same thing. Under this view, the question, why these rules, becomes why this mathematical structure? And the answer might be that all possible mathematical structures exist, and we're experiencing one of them. The rules aren't chosen by anyone, they're inherent in the structure itself, the way the rules of chess are inherent in the definition of chess. But here's where it gets personal, where this stops being abstract philosophy and starts mattering to your life. If matter is just organized energy following mathematical rules, what does that make you? Are you determined? If you're just particles following equations, is your every thought and action just the inevitable result of quantum fields evolving according to Schrodinger's equation and the Standard Model? Or is there something else, free will, consciousness, something beyond the physics? This is where we have to be honest. We don't know. The relationship between consciousness and physical law is one of the deepest mysteries in all of science. We know brains are made of atoms following physical laws. We know neurons fire based on electrochemical reactions governed by quantum mechanics. We can even predict some aspects of neural activity and correlate them with mental states. But we have no idea why those physical processes feel like something. Why there's an experience of being you, of seeing red, of feeling pain or joy. This is the hard problem of consciousness, articulated by philosopher David Chalmers. We can explain the easy problems, how brains process information, control behavior, integrate sensory input. But explaining subjective experience? Why the lights are on? Nobody knows. Some physicists, like Roger Penrose, have suggested consciousness might involve quantum effects in the brain, perhaps in structures called microtubules inside neurons. Others think consciousness is an emergent property something that arises from complex information processing without requiring new physics. Still others believe we need a fundamental rethinking of what physical law is. That consciousness might be as basic as mass or charge, a fundamental aspect of reality, rather than something that emerges from it. But here's what we can say. If you're made of light following rules, then in a sense, the light has organized itself into a pattern complex enough to contemplate its own existence. The universe is folded into a structure that can observe itself, question itself, understand itself. You're not separate from the physical universe. You're a part of it that's become self-aware. And that's not less meaningful than being made of special soul stuff separate from matter. If anything, it's more amazing. The same quantum fields that make up distant galaxies also make up your neurons. The same forces that held particles together in the Big Bang are holding you together right now. You're continuous with the cosmos, made of the same fundamental substance as stars and planets and supernova. When you look at the night sky, you're not separate from what you're seeing. You're the universe looking at itself. You're stardust contemplating stars. You're light that's learned to think. And here's something beautiful. The atoms in your body weren't created in the Big Bang. The Big Bang only produced hydrogen and helium. Every heavier element, the carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, was forged in the cores of massive stars that lived and died before our sun even formed. Stars spend millions of years fusing lighter elements into heavier ones, powered by the strong nuclear force converting mass into energy via E equals mc. When they die in supernova, they blast those heavy elements into space. That material forms new stars and planets. Our solar system condensed from the remnants of previous stellar generations. So the atoms that make you, the matter that's really trapped, light following rules, those atoms were created in nuclear furnaces billions of years ago. They scattered through space for eons, eventually coalescing into Earth, becoming part of soil and water, entering the food chain, and ultimately assembling into you, your recycled star matter, your ancient light that's been on a billions of years journey through the cosmos, briefly organized into a pattern that can wonder about its origins. And someday, those atoms will disperse again, becoming part of other structures, other patterns. The energy that is, you will transform into other forms, following the same rules it always has. Carl Sagan said we're made of star stuff, but it goes deeper than that. We're made of light stuff, organized by mathematical rules that have existed since the beginning of time. Matter is an illusion, a temporary pattern energy takes when confined by forces. You're not a thing, you're a process, a temporary stability in the endless dance of energy, transforming according to eternal laws. Now, let's take this even further. We've talked about how light becomes matter through pair production, how matter is mostly empty space filled with fields, how quantum fields are the fundamental reality. But there's another layer to this that's going to completely change how you think about reality: the Higgs field. You've probably heard of the Higgs boson. They discovered it at the Large Hadron Collider in 2012, and Peter Higgs and Francois Englert won the Nobel Prize for predicting it in 2013. The media called it the God particle, a nickname physicists hate. But what is it, and why does it matter for our story? Remember, particles are excitations in quantum fields. A photon is a ripple in the electromagnetic field. An electron is a ripple in the electron field. The Higgs boson is a ripple in the Higgs field. But the Higgs field is special, unique among all quantum fields, because it has a non-zero value everywhere in the universe, even in its ground state. Every other field, when nothing's happening, has a value of 0. But the Higgs field has a constant value, about 246 GeV, filling all of space like an invisible ocean. And here's the crucial part. Particles gain mass by interacting with this field. Think of it like this. Imagine you're trying to walk through an empty room. Easy, right? Now imagine the room is filled with thick molasses, harder. The molasses resists your motion. It takes more effort to accelerate, to change direction. You've gained effective mass because of your interaction with the medium. The Higgs field works similarly. Particles that interact strongly with the Higgs field, like the top quark, which is very heavy, are like objects moving through thick molasses. They have a hard time accelerating, which means they have a lot of mass. Particles that interact weakly with the Higgs field, like electrons, have less mass. And particles that don't interact with the Higgs field at all, like photons, have no mass and travel at the speed of light. So mass isn't an intrinsic property particles just have. It's a relationship between particles and the Higgs field. Mass is resistance to acceleration, caused by interaction with a field that permeates all space. Matter's substance, the thing that makes it feel solid and heavy, is actually just friction with an invisible quantum field. Let me say that again. The reason matter has mass is because it's constantly interacting with a field you can't see, feel, or detect except through its effect of making things hard to accelerate. Your weight, the effort it takes to lift something, the feeling of solidity, all of that is your atoms dragging through the Higgs field. Without the Higgs field, all particles would be massless like photons, traveling at the speed of light. There would be no atoms, electrons, couldn't be bound to nuclei because they'd be moving too fast. No chemistry, no structure, no you. The Higgs field is why matter exists as something distinct from light. But here's the truly weird part. The Higgs field could have had a different value. In the early universe, extremely early, we're talking 10 seconds after the Big Bang, the universe was so hot that the Higgs field was in a symmetric state with zero value everywhere, just like other fields. All particles were massless. Then, as the universe cooled, the Higgs field underwent what's called spontaneous symmetry breaking. Think of a pencil balanced on its tip. That's a symmetric state. It looks the same from any angle, but it's unstable. The slightest perturbation and it falls. Once it's fallen, it's pointing in some particular direction. The symmetry is broken. That's what happened with the Higgs field. It fell into a non-zero value, and the direction it fell determined the masses of all particles. The specific value it took 246 Chev seems arbitrary. In principle, it could have been anything, but that value determines the mass of every particle in the universe. Change the Higgs field value, and electrons might be heavier than protons, or quarks might be massless. The entire structure of matter depends on this one number that arose from a phase transition in the first fraction of a second after the Big Bang. So not only is matter just light following rules, but the rules themselves specifically, the masses of particles, were set by a cosmic accident in the first instant of time. The Higgs field happened to settle at a particular value, and that locked in the properties of matter forever after. You exist because of how one quantum field randomly rolled when the universe was younger than a blink. And there's something even stranger. The Higgs field's current value might not be stable. Some calculations suggest we're in a metastable state, a local minimum, but not the absolute lowest energy state. Think of a ball in a valley, but there's a deeper valley on the other side of a mountain. The ball is stable for now, but if something gave it enough energy to get over the mountain, it would roll down to the deeper valley. If the Higgs field transitions to a lower energy state, it would be catastrophic. The vacuum itself would change. The masses of all particles would change. Atoms would disintegrate. A bubble of this new vacuum would expand at the speed of light, destroying everything in its path as matter as we know it ceases to exist. The universe would essentially reboot with different physical laws. How likely is this? Nobody knows. It might be stable for longer than the current age of the universe. It might happen tomorrow. The uncertainty comes from not knowing the exact mass of the top quark and other parameters precisely enough. But the possibility exists that reality as we know it, matter, atoms, you, is temporary, existing in a metastable state that could decay at any moment into something completely different. Sleep tight. But let's pull back from potential cosmic catastrophes and think about what this means philosophically. Matter isn't just light following rules. It's light following rules that were set by a random quantum fluctuation 13.8 billion years ago and might change at any moment. The solidity of reality, the permanence of physical law, the masses that make matter matter, all of it balanced on a knife's edge. A temporary configuration in field space that happens to allow complex structures like stars and planets and you. This brings us to one of the most profound questions in all of physics. Why is there something rather than nothing? If matter is just energy and fields, and those fields could be zero everywhere, why aren't they? Why does the universe exist at all? One answer comes from quantum mechanics. In quantum field theory, even empty space, the vacuum, isn't truly empty. Fields fluctuate constantly, borrowing energy from uncertainty for brief moments. Virtual particles pop in and out of existence. The vacuum has energy, zero-point energy, that can never be removed. Nothing is impossible in quantum mechanics. There's always something. But that just pushes the question back. Why quantum mechanics? Why are the laws of physics quantum at all? And here we're at the edge of knowledge. Some theories suggest quantum mechanics itself might emerge from something deeper, perhaps from geometric properties of spacetime, or from information theory, or from even stranger mathematical structures we haven't discovered yet. Stephen Hawking and James Hartle proposed an idea called the no-boundary proposal. The universe has no beginning because time itself emerged from the Big Bang. Asking what came before is like asking what's north of the North Pole. The question doesn't make sense because before requires time, and time didn't exist. The universe isn't something that began to exist. It's something that exists eternally in the mathematical structure of spacetime. Under this view, the Big Bang isn't the creation of the universe. It's just the earliest moment where our current laws of physics apply. And matter-light following rules has always existed in the sense that the mathematical structure describing it exists timelessly. But whether that's right or not, whether the universe was created or eternal, whether the multiverse exists or we're alone, one thing is clear. Matter is not what you thought it was. It's not solid stuff. It's not made of tiny billiard balls. It's energy light, fundamentally organized into patterns by quantum fields and fundamental forces, gaining the property we call mass through interaction with the Higgs field, held together by exchanges of force-carrying particles, arranged into atoms and molecules and larger structures through electromagnetic interactions, and somehow, in sufficiently complex arrangements, becoming conscious and aware. You are light, temporarily organized, following rules written in mathematics, experiencing itself, asking questions about its nature. And that's not a reduction of your significance. It's an elevation of light's significance. Light isn't just something that illuminates objects. Light is what objects are made of. The photons coming from your screen right now are the same fundamental substance as your eyes receiving them, just in different energy states, following different rules. When Einstein said E equals mc, he wasn't just describing bombs and power plants. He was revealing the secret of existence. Energy and mass are one substance in two forms, constantly transforming into each other. And the visible universe is just energy playing by rules in the playground of spacetime. Every particle in your body was once light. It condensed out of the thermal radiation of the Big Bang, or was created in stellar fusion, or emerged from a supernova, or appeared in a cosmic ray collision. It will eventually become light again when you die and decay, and your atoms disperse and perhaps fall into a black hole that eventually evaporates into Hawking radiation. The light is eternal. Your particular arrangement of it is temporary. But that temporary arrangement, you, is doing something remarkable right now. It's understanding. It's contemplating the nature of reality. It's grasping, at least partially, the deep truth that matter is an illusion and everything is energy dancing to mathematical music. This understanding changes how you relate to the world. That wall you're looking at isn't solid. It's mostly empty space filled with quantum fields, with a few electron clouds that repel your hand's electron clouds when you touch it. The sensation of solidity is electromagnetic force, not substance. The wall isn't there in the way you think it is. Your body isn't a fixed thing. Every cell is replaced on timescales of weeks to years. The atoms cycle through you, borrowed from the environment temporarily, returned when you exhale or excrete or shed dead skin. The pattern persists, but the substance is constantly flowing through. You're a whirlpool in a river, a temporary stability in constant flux. And yet, somehow, you persist. Your consciousness continues even as the atoms change. Your identity remains even though you're not made of the same matter you were 7 years ago. This suggests consciousness isn't tied to specific particles. It's tied to the pattern, the information, the relationship between the parts. You're not the atoms. You're the arrangement. You're the song, not the instrument it's played on. This has profound implications. If consciousness is pattern rather than substance, then in principle, it could be transferred, copied, instantiated in different substrates. Upload your brain's pattern to a computer, and you might persist even after your biological atoms disperse. This is speculative and controversial, but it's implied by the physics. If you're not made of special consciousness stuff, but rather are an arrangement of ordinary matter following ordinary rules, then any substrate capable of instantiating that arrangement should produce consciousness. But it also means you're profoundly connected to everything else. The quantum fields that make you are the same fields that make stars and planets and distant galaxies. You're not separate from nature. You're an expression of it. When you look at a tree or a rock or another person, you're seeing different arrangements of the same fundamental energy fields that constitute you. We're all made of light. We're all temporary patterns in eternal fields. This is what mystics and spiritual teachers have been pointing at for millennia with their talk of we are all one and separation is illusion. They didn't have the language of quantum field theory, but they somehow intuited this truth. At the deepest level, boundaries dissolve. Matter is not separate from light. You are not separate from the universe. Subject and object, observer and observed, self and other. These are conventional distinctions we impose on an underlying unity. Physics has arrived at something remarkably similar to Eastern philosophy. The fundamental nature of reality is not stuff, but process. Not being, but becoming. Not substance, but relationship. Matter is light following rules, and you're part of that dance, briefly aware of itself before the pattern dissolves and the energy flows into new forms. Now we're coming to the end of this journey, but before we close, I want to address one more thing. What does this mean for how you should live? If matter is an illusion, if solidity is just electromagnetic repulsion, if you're made of ancient starlight temporarily organized into consciousness, does that change anything? Should you live differently knowing this? Some people might become nihilistic. If we're just particles following equations, nothing matters. But I think that's exactly backwards. The fact that the universe has organized itself into patterns capable of experiencing meaning, that light has learned to love and create art and ask questions. That's astonishing. The rarity of such organization and the vast emptiness of space makes it precious, not worthless. Others might become detached. If everything is temporary patterns, why get attached? But again, this misses the point. The temporary nature of things makes them more valuable, not less. You'll only experience this particular arrangement of matter for a few decades. The people you love are unique patterns that will never exist again once dispersed. That scarcity creates value. What I think this understanding should create is a sense of profound connection and responsibility. You're not separate from the world. You're made of it. Harming the environment is harming an extension of yourself. Helping others is helping other expressions of the same energy fields that constitute you. There's no deep metaphysical division between self and other, only conventional boundaries we draw for practical purposes. It should also create wonder. Every moment, your body is performing quantum mechanical calculations that would crash any computer ever built. Electrons in your neurons are tunneling through barriers they shouldn't be able to cross. Quarks in your atoms are exchanging gluons trillions of times per second to maintain nuclear stability. The electromagnetic force is holding you together against the pressure of electron clouds repelling each other. You are impossibly complex, incredibly fragile, and utterly miraculous. The fact that matter can organize itself into something that thinks, feels, and understands its own nature is perhaps the most remarkable fact in the universe. You're the universe experiencing itself, temporarily, locally, as a human being. And finally, it should create humility. We don't understand everything. We don't know why consciousness exists, why the Higgs field has the value it does, why the universe exists rather than nothing, whether there are other universes, what happens to information in black holes, how to reconcile quantum mechanics and gravity. Physics has revealed incredible truths about reality, but the biggest questions remain unanswered. Matter is light following rules, but we don't fully understand the rules. We don't know why there are rules at all, and we're not even certain there aren't additional rules we haven't discovered yet. Dark matter and dark energy make up 95% of the universe, and we have no idea what they are. We're like ants trying to understand the internet. We've figured out some local patterns, but the full picture is beyond our grasp. That should make us humble, but not resigned. Curious, but not arrogant. Confident in what we've learned, but aware of how much we don't know. Science is the best method we have for understanding reality, but it's an ongoing process, not a finished product. Every answer raises new questions. So here's where we've arrived after 3.5 hours. Matter is not solid stuff, but frozen light, trapped energy forced into patterns by quantum fields and fundamental forces. You are made of particles that are really ripples in fields that permeate all space. Those ripples gain mass by interacting with the Higgs field, are held together by constant exchange of force carriers, and somehow organize into structures complex enough to be conscious. Light and matter are the same substance in different forms, constantly transforming into each other through processes like pair production and annihilation. The rules governing these transformations, conservation laws, symmetries, quantum mechanics are written in mathematics and have existed since the beginning of time, or perhaps are timeless aspects of reality itself. You are ancient, made of atoms forged in stars that died billions of years ago. You are temporary, a brief pattern in the endless flow of energy through space-time. You are connected, made of the same quantum fields as everything else in existence. You are aware, somehow light that has learned to know itself. And that awareness, your consciousness, your ability to understand these truths, might be the most remarkable thing in the universe. It suggests the universe isn't a dead machine, but something capable of producing meaning, value, beauty, understanding. Whether that's by design, by accident, by necessity, or by selection from a multiverse, we don't know. But it is. You are matter. Matter is light. Light is energy. Energy is governed by mathematical laws we're slowly discovering. And somehow, that energy, following those laws, has become you reading these words, thinking these thoughts, experiencing this moment. That's the truth physics has revealed. Reality is far stranger, far more beautiful, far more unified than common sense suggests. Matter and light, substance and energy. You and the universe, all of it is one thing, expressing itself in infinite forms, following rules written in the language of mathematics, creating the grand symphony of existence. You are not separate from that symphony. You are a movement within it, a theme that emerges, develops, and eventually resolves back into silence. But while you play, you are glorious light that shines with consciousness, matter that thinks and feels and wonders, a temporary crystallization of eternity into the particular. So the next time you touch a solid object, remember, you're feeling electromagnetic forces repelling. When you look in a mirror, remember, you're seeing ancient starlight arranged into patterns capable of self-recognition. When you think about your place in the universe, remember, you're not in the universe. You are the universe, locally aware, temporarily human. Matter is just light following rules. And those rules have created something that can understand itself. You? If this journey has changed how you see reality, if you're walking away from this video with a fundamentally different understanding of what you are and what the world is, do me a favor. Hit that like button to let me know. Subscribe so we can explore more mind-bending ideas together. And share this with someone whose mind is ready to be blown. Drop a comment telling me, what are you going to think about differently now? How has this changed your perspective? What questions do you still have? I read every comment, and I'm genuinely curious about how this lands for people. Remember, you're not just watching educational content. You're participating in the universe's ongoing project of understanding itself. By learning these truths, by grasping how matter emerges from light and how the quantum world creates the classical one, you're continuing the work that Einstein, Feynman, Hawking, and countless others began. You're part of the grand human endeavor to comprehend existence. And that matters. Not despite the fact that you're just organized energy, but because of it. The universe has organized itself in such a way that part of it can understand the whole. That's not meaningless. That's the most meaningful thing there is. Thank you for spending these 3.5 hours with me. Thank you for being curious, for pushing your understanding, for being willing to have your assumptions challenged and your worldview expanded. People like you, people who seek truth even when it's weird and uncomfortable, are what drives humanity forward. Now go out there and experience reality with fresh eyes. Touch something solid and feel the electromagnetic force. Look at light and recognize your own substance. Exist knowing you're a temporary pattern of eternal energy. Be the conscious light that you are. This has been why matter is just light following rules. I'll see you in the next deep dive into the nature of reality. Until then, keep questioning, keep learning, and keep being amazed by this strange and beautiful universe we're part of.